Hello, everyone. So have you spent time managing database capacity, worrying about your estimates, worrying about downtime, provisioning extra resources for just-in-case scenarios, because there's only so much you could worry about? My name is Anam Jangshe, and I'm a product manager with Aurora. And in this session, we're going to talk about exactly that. We're going to talk about how Aurora Serverless V2 can help you reduce your operational complexity for managing database capacity and save on cost. So just a high-level overview of what you're going to see in the next 45 minutes to an hour. We're going to start off with an overview and motivation to set the context with how Aurora Serverless V2 can help you. And then we'll jump directly into the auto-scaling capabilities of Aurora Serverless V2. Now, when it comes to your critical and demanding workload, it's not just auto-scaling capabilities that you need. You need all those other additional features of Aurora. So we're going to talk about how serverless works with those features. We're going to touch a little bit on billing, and then we're going to bring it all together with a customer use case study to show you how Intuit has seen cost savings with Aurora Serverless V2. And we'll close it off with how you can get started today. And during the whole session, we'll show a couple of demos so you can see things in action. Now, Aurora Serverless V2 is a feature of Aurora, which is a MySQL and Postgres compatible relational database that is built for the cloud. You get the performance and availability that you expect from a commercial database, but at just 1/10 the cost. It is also the fastest growing service in the history of AWS. Now, at very, very high level, when you're building your application, you figure out how many database resources that you need, and you provision your database based on that. As your workload grows and it goes beyond your estimates, you provision a bigger size machine and you do a failover. Now, let's say your application is coming to end of life. You do the reverse. So you reevaluate how many resources you need, what capacity do you need, and you course correct. Now, let's say your organization has hundreds and thousands of applications, each of which could be backed by a single database or multiple databases. Now, for managing capacity, instead of worrying about one database, you have those hundreds and thousands of databases that you have to worry about. What if you are an ISV or you are running multi-tenant applications, each of which could be backed by, you could be following a tenant per database model for complete isolation, or you could be grouping your tenants together to get better utilization. Now, it is typical for ISVs to have hundreds of thousands of customers. So again, all of a sudden, you have to worry about all of these databases. And over time, the requirement for these databases could also vary. So you have to think about the requirement of each and every one of those. And every time you have to switch machines, there's downtime involved. So all of this to say is database capacity management is hard. Now, a simple solution could be, let's get the biggest possible machine so you don't have to think about moving machines back and forward and just use that. That's not a realistic solution. Somebody has to pay for that. So then you look for some trade-offs. Now, if you want to closely follow what your requirement is for your variable workload, you require expert knowledge of folks who understands the database, understands your workload, and anytime you have to move to a different size database, you have to take downtime. So if your estimate is wrong and you end up provisioning something that's less than the peak capacity that you require, here in the diagram, I'm just showing provisioning for average capacity, but anything less than the peak that your application requires, there's going to be application degradation. So that's not ideal. So one thing you can do is just provision for peak capacity. So whenever you need those resources, you have them. But again, this is an expensive solution because most of the time, you're not using those resources, but you continue to pay for that. So none of these scenarios are ideal. Now, this is where Aurora Serverless V2 comes in. It is the fastest adopted feature in the history of Aurora. We launched last year, and it continues to be the fastest adopted feature that we have. What does it give you? It is an auto-scaling and on-demand feature for Aurora. So what it provides you is, as your application load varies, the database scales automatically. You don't have to do any of that. The database takes care of all of that. You pay for whatever the database resources that the database is consuming. And with this new version, we make sure that we follow your workload closely. So we give you a worry-free database capacity management experience. Now, for the next couple of slides, we're going to talk about under the hood. How does autoscaling happen for Aurora Serverless V2? Now, how should you think about it? So when you are provisioning a database, you're thinking about a fixed size instance. So for example, in Aurora, you could be provisioning an R6G large, which gives you 16 GB of memory and 2 vCPUs. So for the purpose of this conversation, I'm going to refer to that as a provision Aurora database. What happens in serverless, instead of picking this fixed instance size, you give it a capacity range. And based on your workload, the database is going to scale within that capacity range. So on the screen, I saw there's a screenshot of just where we're going to put the capacity range, the minimum and the maximum. Now think of serverless as just another instance that you're putting in your cluster. And instead of specifying a fixed size instance, you're giving a range of it. But it's just any other instance. And it uses the same engine code as Provision Aurora. It has the same security posture as Provision Aurora as well. In terms of versions, for serverless, we support MySQL 8 onwards, and for Postgres, it's 13 onwards. And we have built it such that we have made it easy to switch between serverless and provision. So if you are provisioning any one of those, so if you have Provision Aurora or serverless, you're not logged into that. You can go back and forth between them easily as well, and we'll talk more about it later on. Now, I talked about how the database is going to automatically scale capacity. Now, how do we measure this capacity? So we use a high-level abstraction for capacity measurement called Aurora Capacity Units, or ACUs. What do you get with it? With one ACU, you get 2 GB of memory, and for CPU and networking resources, it is similar to what you get with Provision Aurora. For starting capacity, the database starts off with as small as 0.5 ACUs, which is equal to 1 GIB. So that's a pretty small database. This is what you can start off with, and it can go all the way up to the maximum database capacity. So at provisioning time, you give this minimum database capacity in ACUs and a maximum database capacity. Minimum is the starting point. So this is where your database will start off as. And at all times, you will be paying for that minimum database capacity. Think of the maximum as your budget control measure. At no point will the database scale beyond this maximum database capacity. And when you're thinking of what that number should be, keep in mind what are the peaks that your workload is experiencing. What are the features that you're using? Because you want to make sure that your database has all the resources available that it needs so it can scale up to that. So these are a couple of things that you think about when you are thinking of what minimum to set, what maximum to set. Now, that's just about capacity. Now, when should this database be scaling? What are the factors that the database looks at to make this decision of when to scale? So there are a couple of factors that the database looks at, or deciders as we call it. First one, CPU utilization. Now, it's not just the workload that you're running. So if there's anything that's running in the background that the database is using to keep it healthy, any of the background processes, a classic example would be purge, the database will scale up if it requires those resources. Memory utilization is another one. So if there's load on any of the internal memory structures, the database adjusts capacity to make sure your workload has those resources available. And the third factor is network throughput. If it requires more network resources for anything, it's going to scale up to provide your workload those resources. To make the scaling decision, if any one of these factors require resources, the database is going to scale up. So let's say if it needed a little bit of CPU resources, it's going to scale up. But for scaling down, none of these factors should require resources before the database initiates the scale down process. Now, this is about what are the factors that we are looking at. How does the database actually scales now? We scale by what we call as in-place scaling. What we do is we take a running database process and we give it more resources. We give it more CPUs, more memory. So whatever the database requires, we give it those resources. And we scale by in place. The other factor is non-disruptive scaling. The way we build the architecture under the hood, we're not switching the machines or doing any of that. So there's no disruption caused when it's scaling. You could be running hundreds and thousands of transactions, and the database will still scale when it requires resources. So we provide non-disruptive scaling experience. The third point I want to highlight is that Aurora Serverless V2 scales in fine-grained scaling increments. What we mean by that is if your database just requires a little bit resources, it has the capability to scale just by a little amount. So the smallest that can scale in terms of increments is 0.5 ACUs. So let's say, an example, it's at 12 ACUs, and the database needs just a little bit push. We can scale up to 12.5 to give it those resources. So at all points, we want to make sure that the database is following very closely to your workload, so you're not paying for extra resources. And lastly, when your database requires resources, your workload requires resources, the database should react instantly. So serverless scales instantly to give your workload those resources. There's no lag or anything. It'll scale right. And the way we design the scaling experience is we want to make sure that there's predictable scaling. It's instantly, yes, but we also want to make sure that it shouldn't be that one day something happens, the next day something else is happening. So we provided a very consistent scaling experience. This scaling experience is based on a token-based system. So imagine each instance gets a bucket of tokens, which are characterized by two parameters. You have the bucket size, and you have a refill rate. So at each instance size, it comes with a bucket size that instance can consume instantly. So if any of the deciders tell the database needs resources, the database can scale right away with whatever's available in the bucket. So that gives you the instant scalability. Now, what if you need more resources? Then the bucket is also getting refilled at a sustainable rate. So then your instance can continue to scale up to make sure that your workload has the resources that it requires. Now, what determines what the bucket size is or what the refill rate is? It is based on the size of your instance. Now, a trend line showing how do the bucket size changes. It varies based on the instance capacity. So bigger the instance capacity, bigger the bucket size will get. So it can scale instantly more. And then same goes for refill rate too. It has a very similar trend that bigger the instance size, faster the refill rate that you get. And with all of that, it makes sure that bigger the instance size, the faster your database can scale. So when you are testing your application, look at the scaling rate. If you feel like the scaling rate is not up to the requirement of what your application requires, what can you do? Right now, I'm talking about it's the current instance size. What you can do is you can change your minimum database capacity because, as I said, that's the starting point. That changes what the size of the database would be. So if you want a faster scaling rate, change the minimum ACUs, and you'll get that. So for example, if you have a launch coming up, you already know that there's going to be surge. You can increase that minimum to make sure that you have that faster scaling rate. Now, this is about how does the database scale. Let's go into a little more details about buffer pool. What happens to it during scaling? So buffer pool is your primary cache of the database. It also scales when the database scales. Now, so the parameters you're looking at is for MySQL, it's InnoDB buffer pool size. For Postgres, it's shared buffers. So we're scaling these parameters when the database is scaling and it requires more resources. In terms of memory allocation, it mostly goes to buffer pool. Around 25% goes to heap. Now, when the database needs to scale down, it does it through a combination of least frequently used and least recently used algorithms. Now, let's quickly look at how does the whole buffer pool scaling works with a simple animation. So as pages are read, they get hotter and hotter. And if you have new pages coming in for storage, you don't know what the future access pattern is, so we want to make sure that these are least likely to be evicted. So they come in as warm pages, and as they get read, they become hotter and hotter, and those are the least likely to be evicted. So it's the pages that are depicted in gray, the cold pages, that are the ones that are most likely to be evicted when the buffer pool needs to scale down. So we're going to evict those pages, reclaim memory, and shrink the buffer pool. Now, I talked about how scaling up was instant, because when you need those resources, you want to make sure you get them right away. But for scaling down, we want to be cautious. We want to make sure that we're not prematurely evicting these pages that you may need, and then you have to go fetch them again. So for scaling down, we take a more cautious approach. And in the demo, you'll see how you're going to see this intentional stepwise decrease for scaling down. Now, the database can continue to scale down, and it comes down to the minimum that you have configured. Now, there could be scenarios where it doesn't come down to the minimum. Now, why is that? We talked about how if your database needs any resources, be it resources for the workload or the queries that you're running, or any background processes that the database could be doing, anytime it needs any of those resources, the database is going to scale to that level where it can sustain that workload. Now, there are some factors where you're not running any workload, but there's something else going on in the database. It could be the background processes such as vacuum or purge, where it requires the resources, but your minimum is, let's say, 0.5 ACU, which the resources that you require are more than that. So then the database is not going to come down to the minimum that you set. It's going to stay at the level where it needs those resources. The second factor could be some of the features. For example, again, if your minimum is 0.5 ACU, and you're using any features such as global database, which requires more resources, the database will stay at the level where it can operate that feature healthily. Performance Insights is another example of the feature where it may require more resources that a 0.5 ACU database cannot sustain. Another factor is, what if you have a large storage size attached to your database? In those scenarios, the database is also going to stay at the level where it can sustain that workload. Failover priorities here. So if you have set a priority tier of 0, 1, and we're going to talk in more details later on about it, this could be another factor where the database is not going down to the minimum that you set. So overall, what you should be thinking about is the database capacity will stay at the level where the database has all the resources it requires for your workload. You can set the min and the max, but the database will automatically scale up to make sure it can sustain that workload. Now let's quickly talk about parameters, how they're handled. I've given away half of the slide before because we talked about buffer pools. So there are some parameters that we automatically adjust during scaling time. So buffer pool is one of that. So for Postgres, shared buffer is that parameter. Then there are other parameters that are going to be changed when you change that maximum ACU, your maximum capacity setting. So there's a list of those parameters too, for example, maximum connections. And of course, always look at the documentation for the up-to-date list. Here, I'm just showing a few of them for Postgres. And similarly for MySQL. So parameters that change during scaling, and then there are parameters which will change when you change the maximum capacity. OK, so this is all about scaling, how it happens, what goes on. Is there going to be enough capacity lying around for your database to actually scale? Because we can understand all about scaling, but what if there's no capacity? How do we make sure that there is enough capacity available? So first thing, we do capacity planning for in-region. With our experience of running Aurora and RDS, we can make projections based on that. So that's one. Secondly, we do call this serverless, but at the end of the day, we are running this on actual machines with finite capacity. Now, what if that underlying host, that runs out of capacity? What do we do then? So Aurora has the capability to make sure that we can move instances around non-disruptively to make more room within that host so your database can scale up. And we want to make sure that this background movement of instances, While we're doing it, we preserve state. So we preserve connections, your buffer pool. So from your side, you won't see that difference. We're just moving things around to make sure there's enough capacity available for your database to scale up. Now, this is just a little sneak peek into how do we manage heat at scale. What you're seeing on the graph is x-axis are host numbers and y-axis capacity. Each blue dot represents an instance, and the purple dots that are scattered all over are very, very large instances. And a vertical line composed of blue dots, those are single hosts containing all of these instances. This just shows that when your host reaches a certain threshold, we move instances around to make sure there's enough room. And a black arrow left and right is going to appear to just show that how instances are moved around. I'm just showing a small region to give you an idea. So you see that black arrow appearing. That's to move instance away from the host to make sure there's more room for other instances that were the databases that were growing. And this is just a little sneak peek into how is it all working at scale. Now, one thing is understanding how scaling works, but what can you do to monitor your database? So with Aurora, there are various different capabilities that gives you the monitoring capability, for example, for instance, for your operating system, for database engine. With Aurora Serverless V2, all of this also works. And we have built additional metrics on top of that and additional features to make sure that what you need for Aurora Serverless is available. And we're going to touch on a couple of metrics, key ones only. So let's start with CloudWatch. We have this metric called serverless database capacity, which represents the current capacity of your instance. So when you are provisioning, you're only giving minimum and maximum, but any point in time, what is the capacity of the database? This is the instance that's going to tell you that. So here, if you see, there's like constant capacity in ACU, then it scales up. You see that, then it's scaling down. Then we have ACU utilization, which is the corresponding percentage of the current capacity out of the max. So now what this tells you is if this is coming too high, you're coming to 80%, 90%, you have a certain threshold. Either you go optimize your workload, so it requires fewer resources, or you can increase your maximum database capacity so you have additional resources available. Another one is CPU utilization, which is, again, a percentage of CPU based on the maximum ACU. Again, if it's coming close to a threshold, your database requires more resources, you can change the maximum database capacity to give it more resources. And the last one I want to touch is freeable memory. Same as you have also seen this in Provision Aurora as well. So it's the total memory that is available to the database engine. Now, if it reaches to a point where not a whole lot of memory is available, again, you can increase the maximum database capacity to give it more resources. The next feature I want to touch is Performance Insight, which gives you a simple yet powerful tool to monitor your workload in terms of active sessions. Now, for serverless, you want to be paying attention to this dotted line. It's the estimated vCPU that I've highlighted. The text is like super tiny. Now, you see that where it goes up, this is where scaling is happening. You see that blue bar, because the buffer pool scaled up, but you still need to warm it up. Once it warms up, then the blue bar becomes smaller, which is your data file read. So Performance Insight can help you identify bottlenecks as well. And there, you can go optimize your workload, or you can increase your maximum ACU to give your database more resources. Now, let's look at a simple demo to see how you can get started with the Aurora Serverless V2 and see scaling in action. Now, this is RDS console. To create a database, this is very similar to what you do currently with Aurora. Pressing the orange button, you get into the same workflow for creating a database. Nothing is different here. You have standard create, you have easy create. So it's the same options that you are already familiar with in Aurora. For engine type, select Amazon Aurora. And when you're looking at edition, you have MySQL compatible edition and Postgres compatible edition. So serverless works for both of them. For MySQL, as I mentioned, the versions that are supported are 8 and onwards. So all new versions that will come in will also support those at the same time as provisioned Aurora. If you look at Postgres editions, it's Postgres 13 and onwards. And as you get more and newer versions, those are going to be supported with serverless as well, too. So you give it a name and password. Now, for instance configuration, this is where you select a fixed instance. So you have, R5 large or any of these. So this is where the settings are going to change to. Now you're selecting serverless, and you get this range that you have to specify. You can pick default as well. So you have the minimum ACU, which is the starting point for your database, and the maximum ACU setting. And when you're just test trying, you can go ahead with the minimum and the maximum available. So now for availability, durability for this demo, I'm going with all defaults, so not going to select any other options. So this was to show that to create Aurora Serverless V2, you just have to specify that capacity range. Everything else can stay the same. And when you refresh it, in your cluster, you will see that you have a Serverless V2 instance, and it gives you the range that you selected. To show scaling, we're using this app, which is basically, you get a question, you select an answer. So it's an event-driven app. And here, this is just a sample question to show it. And when there is workload coming to the database should adjust capacity to show that. Now, I'm going to use just a sample data set. Here, we're just initiating start of the workload. Now, what you should see is when this workload started, the database should adjust capacity that we are going to observe through this CloudWatch dashboard. Now, what does the blue line shows? That's your database capacity in ACUs. When the workload's starting, you're going to see 2 more lines, red and brown. So one is users are coming in, they're registering, and then they're casting their vote. Just give it a second there, and you'll see workload appearing. And then you should see this blue line respond to that workload coming in. So here, there's overlapping red and brown. That means workload has started, and you see this blue line responding to that workload coming in. As the workload increases, you see this almost vertical blue line. This is where instant scalability happens. Whatever's in the bucket, the database gets that. And it scales up to the point where it can sustain the workload. If more resources are needed, it'll continue scaling, but it'll get to the point where it can sustain that workload, or it goes up to the maximum that you have configured. The more users are coming in, they're casting their vote, and the database capacity stays at the level where it can sustain this workload. Now, the red and the brown line have gone down, meaning that users have stopped registering, no voting is happening, but the database capacity, the blue line, it didn't drop vertically down right away. We paused because we want to make sure we don't evict those buffer pool pages prematurely. So you see this intentional step down for database capacity. We scale down a little bit to make sure do you need capacity, your workload needs capacity or not, and then it continues to scale down. And then you get the final result. It's a pretty even mix, so you can tell the numbers are fudged. I didn't want to take any sides, so this is how scaling works with Aurora Serverless V2, where you get instant scaling up that you saw with an almost vertical line. And for scale down, it took a very cautious approach to make sure that resources are available and we're not prematurely evicting buffer pool pages. Now, that was all about how autoscaling works. For your critical demanding workloads, what about all those other features that you're using with Aurora? How do those work with serverless? Now, first, let's look at where does serverless actually fit in. This is a very, very, very high-level overview of the architecture where I want to highlight some key points. With Aurora's architecture, you get separation of storage and compute. In this diagram on the screen, what you're seeing is across 2 availability zones, you have provisioned Aurora instances with a storage layer. You have R6G in AZ1 and AZ3. Where does serverless fits in? At the compute layer, any one of these nodes could be serverless. So you could add a serverless reader. This is just like any reader that you have with Aurora. If your reads are all variable in nature, you can have all your readers to be Aurora Serverless V2. Or if you have a workload that's just spiky in nature overall, you can make all of these instances to be Aurora Serverless V2. So your entire cluster is a serverless cluster. So this basically shows that you can mix and match your provision instances and your serverless instances. Now, what about storage? So we use the same storage layer as Aurora provision storage layer. So those nodes are the writer and the reader. They're operating on the same storage layer. We're not replicating storage. So storage is spread across 3 availability zones, always, always, always. This is what gives you the high availability that Aurora has. We save 6 copies of data across these availability zones. If something happens to 1 copy, no worries. You won't even see the difference. There are 5 other copies lying around. And keep in mind, you're only paying for that 1 copy. And even in scenarios where the whole AZ goes down, again, you won't see the difference or no, because there are 4 other copies lying there, and then everything will just continue as it is. As your workload grows, the size grows, the storage layer also automatically scales up. You don't have to do anything. If the data size for some reason reduces, the storage layer will also reduce in size. So all of this happens automatically, and you're only paying for storage for how much you're using. Now, what about high availability and read scalability with Aurora Serverless V2? So with Aurora, you get the capability to create up to 15 read replicas or readers. And with serverless, it's exactly the same. And you can use any combination mix and match depending on your workload. For serverless, what you do is you specify the capacity range at cluster level, and all instances are going to inherit that capacity range. With Aurora, you have the capability of automatic failovers, where if something happens to the AZ, it's failed over to a reader instance. And the way it determines that is based on priority tiers between 0 and 15. So smaller the priority tier, higher the priority. So in provision world, it's easier because you know the size of the database. There's no guesswork involved there. If something happens to the AZ, you fail over to that particular machine. But with serverless, you don't know at what size that instance is at. So what we have done is for priority tiers 0 and 1, we have made it such that if your reader instance has a priority of 0 or 1, it's going to follow this capacity size of the writer. So commonly known as reader follow writer behavior. So if you have set those priority tier, you could be having a workload for that particular instance, but it's also going to make sure that it's ready to take over the writer in case something happens to the AZ. And for read scalability, if you don't want this coupled behavior, all you have to do is set your priority tier to be 2 or onwards, so any number from 2 to 15. And in this example here, I've shown like extreme cases of 14 and 15. So for these reader instances, they're not going to be looking at what's going on with the writer. And similar to provision as well, you can spread these serverless instances across different availability zones for high availability. And multi-AZ Aurora cluster is supported by 4 nines of availability SLA, and the same applies for serverless. So none of that changes in serverless. So in this animation, I want to quickly show you how high availability and read scalability works with serverless instances. So here you're seeing 2 applications. So one, you have the primary application and a reporting app, and you're seeing endpoints. So Aurora provides capability to create various different endpoints where you have cluster endpoints, your reader endpoint. Here I'm showing 2 different types. So you have a cluster endpoint. The application talks to your cluster endpoint, which always connects to your writer instance. So there's workload coming to the writer instance, and it's going to scale up. The writer is scaling up. Now, any of the readers that you have in this cluster that are priority tier 0 or 1, those are also going to scale up for this reader follow writer behavior. Now, you could be bunching together a group of other reader instances for requirement of a separate reporting app, which has a different spiky behavior. So here we have a reporting app that talks to a custom endpoint that's in turn talking to those two instances for this particular example. Now, you saw when the writer scaled, nothing happened to these instances. But when there is load coming from the reporting app, with these priority tiers of 14 and 15, these instances are going to scale up. Now, in this behavior, so if you don't want the coupled behavior, make sure to set your priority tiers to be 2 onwards, so 2 to 15. Now, if your application has requirement for global application or you want disaster recovery across region, what you do is you enable global databases. And what that does is it replicates storage to a secondary region. So this is storage layer replication. And under the hood, we also create replication servers and agents that you don't see. And what's happening is that with global database, you get low latency read scalability across these different regions. In terms of lag, think of it typically less than 1 second. Global database gives you availability to create up to 5 secondary regions. And for each of these regions, you can, again, create up to 15 reader nodes. So in total, you can have 90 readers to scale your reads. Now, it also has the capability to provide write forwarding for occasional writes from your secondary region back to your primary region. And it's available for both engines, MySQL as well as Postgres. And in case of a disaster, if one region goes down, a secondary region can take over, and typically you'll see a downtime of less than 1 minute. Where does serverless fits in? Now, any of these compute nodes that you have, they could be serverless nodes as well. So I've shown serverless by these vertical arrows. When these nodes are idling, nothing's going on, you only pay for the minimum capacity. In case of a region failure, when the secondary takes over, serverless instances will scale up to support that workload. Or if you have these regions for read scalability, so these instances will scale up when there's workload on these instances. Now, what if you're running applications that are opening and managing lots and lots of connections, and it could be to get a quick response time? Now, this could be happening if you have serverless application, Lambda functions, that can scale up to hundreds and thousands of applications. And you want your database to respond to that as well, too. You may not be using all these open connections, but they're still consuming your database resources. And you want to save your database resources for their actual job, to run your queries, to run your workload. So what you can do in this scenario is you can use RDS Proxy, which is a fully managed, highly available database proxy that's supported for Aurora Serverless V2 as well. You can place this proxy on top of the database, and it takes the brunt of opening and managing all of these connections. What it does is take lots of those application connections and maps them to a smaller number of database connections by sharing connections. It also gives you better availability. You get 66% faster failover times because there's no DNS propagation delays. So it's constantly looking for what is going on with the writer. If anything goes wrong and there's a failover, then RDS Proxy will connect to the new writer. And in the meantime, it's holding and keeping all of those connections open, so you get better availability for your application. It also gives you better security by integrating with AWS Secrets Manager. And you can use IAM authentication as well with RDS Proxy. So all of those features that you have for RDS Proxy, it works as it is for serverless as well. Now, what if you're doing analytics? You're saving all of that data to get insights from it. So in those scenarios where you are building analytics pipeline, Aurora makes it easy for you with zero ETL integration, where you don't have to build those complicated pipelines to get insights from your data. Now, let's say if you're using Lambda functions, for Redshift, you're using Redshift Serverless to get insights out of it. In this end-to-end pipeline, for your transactional database, you can use Aurora Serverless V2. So you can go all the way from data to insights in a serverless pipeline. And you don't have to build any of those complicated integrations with zero ETL. And you're only paying for the resources that you're using with Serverless V2 as well as on the Redshift serverless side. Now, how does billing happen? What's different about Aurora Serverless V2? In terms of billing, for Aurora, you get billed on various different dimensions. You have your instance, storage, IOs, backup storage. Everything stays the same for billing except the instance one. So Aurora Serverless V2 billing falls under the instance billing. So the unit is ACU hours, and we do per second billing for serverless. So if I do a simple example, like if you're using 10 ACUs per hour, for a month, 730 hours. And if you look at the price for your region, in this simple example, we are using US East, you get $786 for the month. So for billing purposes, instance is where you're looking at. Everything else stays the same. Now we also introduced another cluster configuration that we call Aurora IO Optimized. Now what this gives you is better price predictability for those IO-heavy workloads. And you also get better price performance through the storage layer enhancements that we did. For this feature, what happens is that you get billed for your compute and your storage and no charges for read and write IOs. There's an uplift on the compute and the storage, and as a result of all of that, you're not getting charged for read and write IOs. And where does serverless comes in? As I mentioned, it's at the compute layer. So there's a 30% uplift on compute and a 125% uplift on storage consumption. So this way, you can make sure that there is predictability on your price for those IO-heavy workloads. So IO-Optimize is available for all flavors. So it's supported for provision as well as serverless as well. Now, let's bring it all together to see how one of our customers got cost savings by using Aurora Serverless V2. So Intuit is a financial management company. So think Credit Karma, TurboTax. So they started working with us a while back. They had a bunch of requirements around what they needed from their database. They already had provisioned databases, and they were looking for more cost savings. So their key requirements were around read scalability. They want to make sure that they can scale their reads. They want to make sure if there's a primary node failure, the database recovers from it. And if there's a region-wide failure, there is disaster recovery also available. And with all those features, they want to make sure that we provide it in a cost-effective way, and at no point are they overpaying for their resources. So with all those requirements, so they were already using Provision Aurora, and they had all these features that worked well for them, and they were looking for ways to reduce cost. So this was the previous architecture before. So there are two regions. This, I'm only showing like one of the a cluster with two regions. They have a cluster endpoint, which is talking to the writer, which is a 4XL, and the reader endpoint in the same region with an other provision instance. And for disaster recovery, there's an other provision instance, which is a 4XL. So at all times, they're paying for that provision instance, even though they're not using it. And the rest is, at the bottom, you see the storage layer and all of that. So now what they did was they started evaluating Aurora Serverless V2 to see can they get cost savings for workloads where it's variable and they're not using those resources, but they're still paying for it. So they tested it. They started seeing cost savings. And in their after architecture, you see that they replaced Aurora Serverless in their secondary region. So their disaster recovery instance is in Aurora Serverless V2. It stays at the minimum when it's not being used, so they're only getting billed for that minimum capacity. When it gets used, the instance will scale up and support the workload. For the primary instance, they also added serverless there with future plan of adding more. So in this architecture, they're using some of the key Aurora features around deploying across multiple AZs, disaster recovery with global database, and has serverless to get the cost savings. So with this architecture, they moved not just their non-production databases, as well as their production databases as well, and were able to get up to 55% cost savings. Now, how can you get started? In the demo, I showed how to create it from scratch. How do you create a new serverless database? It's the same as provision. You just specify the database capacity. Now, what if you already have a provision cluster? So to get started for that, to create a serverless instance, you can, in your existing cluster, you can create a reader. It's your typical reader that you have. Now it's a serverless V2 reader by specifying the capacity. And then once you've tested, everything works as expected, you can just do a failover, and then your serverless becomes the writer for that instance. Now you can keep the provision reader there, or you can delete it. Now that was if you have a provision cluster. Now with launch of Aurora Serverless V2, we have two versions of Aurora Serverless, Serverless V1 and V2. So if you are one of our customers who are using Aurora Serverless V1, how can you upgrade that cluster to Serverless V2 today? Now, we have made optimizations recently that can help simplify that for you as well. What we have done is we've added additional parameters in the modify DB cluster API that can help you do in-place upgrade from Serverless V1, which is the previous version, to the new version, Serverless V2. It does in-place scaling, so you don't have to do backup and restore anymore. With in-place scaling, think of it similar to when you do a failover. So less than 30 seconds downtime, and from Serverless V1, you can get to a provision Aurora cluster. So as we talked about, that Serverless V2 is built on top of provision cluster. So this is where you could do in-place upgrade to provision Aurora, and then the versions are different. So with V1, it's 5.7, for example, for MySQL. You have to upgrade to 8.0. So you can use blue-green deployment to safely and securely do that upgrade. And then the step is just add a simple a reader, which could be a serverless reader. I'm going to show you a quick demo just to show like the different steps, and it's going to go by really quickly. I'm also doing the upgrade. That takes a little bit time, but I just speed it up in the video so we can cover it out. So you're starting with the previous version of Aurora Serverless, which is Serverless V1. All you have to do is run the modify command, which we have added those additional parameters that's going to help you do the in-place upgrade. Once you run that, the cluster configuration changes. Now it becomes a provision Aurora cluster. You have the cluster, you have one instance. You can run a blue-green deployment on that cluster to upgrade from, in this example, I'm going from 5.7 to 8.0. So you have blue cluster, you have green cluster, and the green cluster is where the upgrade's happening. This is where I'm going to add a serverless instance now. And I'm going to do all my testing on that green. So once I refresh, as you can see in the cluster, there are two instances, a writer and a reader. So the reader was the serverless reader that we just added. We're going to do a failover to make it a writer. Again, less than 30 seconds downtime to make it into a writer. So this green cluster now has a primary, which is a serverless instance, between 4 to 32. Now, you can test this to make sure everything's working as expected. And then for your blue-green deployment, you can do a switchover once you have made sure that everything is working according to plan. Now, to summarize, bring it all together, what you saw in the last 45 minutes was how serverless can help you reduce your operational complexity and save on costs. It does so by automatic in-place and non-disruptive scaling. We built it on the same architecture as Provision Aurora. So then it works exactly the same way with the additional auto-scaling capabilities. So all other features are also supported. So multi-AZ deployment, read replicas, global database. You briefly saw how billing works. You saw how one of our customers, Intuit, were able to get cost savings by using Aurora Serverless V2. And lastly, you saw how you can get started today using the APIs or a few clicks on RDS console to quickly get started with Aurora Serverless V2. That is all I have for today. Thank you very much, and I'm really excited to see what you build with Aurora Serverless V2. And don't forget to do the survey. Thank you so much, everyone.